everybody, welcome back. This is Unit 3, Lesson 1. And in this unit we're going to be talking about nuclear chemistry, or specifically studying the nucleus, and only the nucleus of atoms. So when we talk about nuclear chemistry, we'll be talking about radiation and what radiation is. And there's different forms of radiation, like light is a form of radiation, and sound radiates, and microwaves radiate, and infrared is a form of radiation. Those are not the forms of radiation we're talking about in this unit. When we talk about radiation in this unit, we're talking about something called ionizing radiation, which in simple terms is really bad radiation. It's the stuff that when you're exposed to it, mutates your DNA and changes it, and can lead to cancer, and can lead to burns, and can make you sick, and can cause death. So we're talking about ionizing radiation, which is really the bad form of radiation, okay? Where does it come from? Well, you're exposed to radiation in your everyday life. And if you take a look at this little animation, this is from NOVA. This will tell you where there is radiation in your environment. So if you click on each of these little things, it'll tell you that the sun emits radiation. Because the sun is powered by a nuclear reaction, it's powered by fusion. It emits radiation that is necessary, like sunlight, which is not necessarily so bad, but also ionizing radiation that are dangerous. Obviously, it emits heat too, which is pretty important. This looks like a farm. Some factories actually dispose of radioactive waste in landfills, and eventually that, if it's not licensed to treat radioactive waste, it can get inadvertently leaked into our environment. In our atmosphere, there's cosmic radiation from the formation of the universe, and also from nuclear weapons testing back in the day when they would do atmospheric testing of nuclear weapons. There's residual radiation left from there. In our oceans, again, two sources, also from nuclear weapons testing, but nuclear power plants can release radioactive waste into the water. They use heavy water as a coolant. There's radiation naturally in our Earth. Uranium is found in our Earth, and that undergoes decay. And there's radon gas in our Earth. Radon gas is the second leading cause of lung cancer behind cigarette smoking. It's odorless, it's colorless, but it can kill you. It's radioactive. And then, of course, foods that we eat, in smoke detectors in your home, in your watches, even you are made of carbon-14, which is radioactive. So many of the foods we eat have radioactive isotopes in them. So it's pretty much everywhere. And you can see that most of what we're exposed to comes from our exposure to radon gas. You don't know you're being exposed to it, but Home Depot and other stores like that actually sell radon test kits that you can put in your basement to see if you have any exposure to radon gas in your home. Because otherwise you wouldn't know. You might just get sick. So what radiation is the release of particles or rays. Oh, there you go. From an unstable nucleus. Okay? So the nucleus doesn't stay together. It's kind of like an upset stomach, right? When you have an upset stomach and you don't feel so good, usually what you do is you vomit or you spew. And that's what an unstable nucleus does. So an unstable nucleus is like an upset stomach. It's not really together very well, and what it does is it spews things out of it. It spews either particles or rays, and we'll talk about what those particles or rays are. What makes a nucleus unstable, or what determines stability? Well, basically any element can have unstable isotopes. Hydrogen has unstable isotopes, carbon has unstable isotopes, anybody can really have unstable isotopes. But if you have an atomic number of 83 or higher, you don't have any stable isotopes. You have only unstable ones. So every element on that periodic table that is atomic number 83 or higher is completely radioactive. You do not find any non-radioactive forms of that element. Whereas elements less than 83, there are stable forms, non-radioactive forms, and there are unstable forms. So I should clarify, because in our last unit we talked about the electron configuration being stable or unstable. This is different. We're talking about the nucleus here. And what makes a stable nucleus is a good proton to neutron ratio. Typically we mean when the proton to neutrons are the same, that nucleus is stable, or when that proton to neutron ratio is 1. So any element with an atomic number greater than 82 is completely radioactive and unstable. Generally, when the proton to neutron ratio is close to 1, the isotope is stable. So for example, if we look at carbon 12 versus carbon 14, okay, the first isotope is stable by William, and that has 6 protons and 6 neutrons. So if you were to get that ratio, 6 divided by 6, that would be 1. The second isotope, carbon 14 here, is actually radioactive. It has 6 protons but 8 neutrons. So that ratio is not 1, it's less than 1, right? If we reduce it, it's 3/4. That's 0.75. So that ratio is less than 1, and this one is unstable and radioactive, and it will spew things out of the nucleus in an attempt to become stable. Okay? So an unstable nucleus means that the nucleus actually breaks down, things go flying out of the nucleus in an attempt to become stable. And those things that go flying out of the nucleus are the things that are bad for us. So if we're exposed to those things, that can cause burns, it can cause illness, it can cause death even. And we'll read an article in class about a man that it was actually poisoned to death through radiation. A Russian spy, it's pretty crazy. Here's what's neat. When you spew out of your nucleus, you turn into someone else. And I wanted to show you an example of this real quick, and we'll tell you what that's called. Okay. So this is, I don't know if I could pause it. Let me reset it. This is going to start with polonium. If you take a look over here on the side, you'll see that it begins with polonium 211, and polonium has an atomic number of 84. So it's completely radioactive and will spew things out of the nucleus. This will represent the nucleus of polonium. It actually, I think it spews out an alpha particle, but don't worry about that. What's important is that here it is polonium, and it spews out particles, and if you notice, it's not PO anymore. It's turned into PB. It's actually changed from polonium, PO, into lead, PB. It's turned into a new element by spewing things out of the nucleus. Okay, we could do a custom one. Let's see. Oh, I guess we'd have to make it. Oh, that was interesting. Let's try. I can show you a bucket of polonium that do that. Oh, I have to add the nuclei. So there they are. And again, you can see that they're spewing, and as they spew, they turn into lead, which is stable. It's not radioactive. They're representing it radioactive by shaking. So there's a name for that. When you spew radiation and you turn into a new element, we actually call that transmutation. So it's the process of one element changing into another through the release of radiation. And I'll give the example that you just saw on the screen. So we had polonium-211, and polonium is atomic number 84. And it spewed out an alpha particle. Don't worry about this. This is the radiation that it released. Okay? And when it did that, it turned into lead, if you remember. And it had, that lead was lead-207, and lead's atomic number is 82. So the polonium turned into lead through the release of radiation. Okay, I'll give you one more example of that. I'll use the carbon-14 that we just saw. Carbon-14 does not spew alpha. Carbon-14 spews beta decay. It undergoes beta decay, which is an electron. So it spits an electron out of its nucleus, which is kind of weird, and I promise I'll talk to you about how that happens too. But it spews, and it turns into a new element. And that element is nitrogen. So carbon transmutates or turns into a new element through the release of radiation. So when things undergo radioactive decay, they become new elements. They're actually changed, their number of protons, and turned into a new element because these are nuclear changes. Okay. Tomorrow in class, we'll talk about different radioactive particles that you've been exposed to a little bit, and we talked about those on Table O. That's it for tonight, everybody. Have a great night.